Hi, I'm Matthew. I'm a data and AI lead at Newfront Insurance. And today I'll be talking about why LLM eval is not all you need when it comes to evaluation. This talk is going to be grounded in my experience building Benji, Retrieval Augmented Generation, or RAG chatbot. Benji is an AI assistant that assists employees with making the most out of their employee resources. And we have it deployed currently through a mobile app and Slack. So this talk will be grounded in a RAG chatbot, but if you're working on or interested in other types of AI systems, if your AI product requires context, this talk will be relevant for you. So similar to how a chatbot needs to retrieve information to generate an answer. For example, if you're interested in how coding copilots work, those also have to retrieve code from the code base. So before I get into the meat of the talk, I want to go over who will find this talk useful. So this talk is at a more intermediate level. So if you're in the introductory or intermediate stages of working on an AI product as a PM, an engineer, I think you'll find this talk really useful. If you're pretty new to AI, we're going to be getting pretty deep into practical challenges faced when trying to productionize AI systems. So this might be a bit dense and unrelatable, but still may be useful. So why should you take advice from me? I've been working on RAG and evals for almost 3 years now, for a very mature AI product that we've already shipped to many enterprise customers. And I've been doing it at a leading innovative insurance tech company that was a YC startup, and now it's a highly valued unicorn. And so hopefully I'll be able to impart something useful today. So like I said, this talk is more at the intermediate level, but I will do really quick crash course, let's say, on how some of the basic building blocks work. So the first key concept you have to understand this talk is how RAG works. And just in the name, you can understand a lot about it. So RAG stands for Retrieval Augmented Generation, and that reflects its two-part architecture. So there's the retrieval and then the generation part. So the first part, retrieval, collects all of the relevant context required to answer a question. And the second part, generation, uses LLMs to synthesize that context into a useful answer. The second important concept is evaluation. Evaluation is just a fancy word for measuring how well your AI system performs. There are a lot of ways that it's important. I'd say the best way to frame it in one statement is you can't improve what you can't measure. If you want to make your AI product better, you can't make it better without knowing whether you're actually improving it. And evaluation is the way to do it. Cool. So I'll start with talking about answer evaluation and its challenges. And when I say answer evaluation, this is synonymous with LLM evaluation, right? Because we're using LLM to generate the answer. To caveat what I'm about to say, the answer is the most important thing to evaluate. If you're working on a chatbot or something like that, the final response you give to the user is almost the entire user experience. And so what I'm trying to say is not that answer evaluation isn't important or you shouldn't do it, but rather there are other necessary ingredients that you should include in your evaluation suite. So there are a couple of variants of this, but this is the way that I think makes the most sense in terms of how do you evaluate answers? How do you test if the answers from your AI product are good? So the first part of it is your LLM pipeline that you would put into production. So a user asks a question, you go and try to retrieve all the relevant context based on that question, and then you generate an answer and return that to the user. So outside of this is your evaluation infrastructure, and that has two main parts. The first is labeling answers. Labeling is just a fancy word for saying we need to get correct answers. So we know that when our LLM pipeline produces the answer, we know whether it's correct or not based on the correct label. The second part of the evaluation is actually doing the grading. So you have your result from the LLM pipeline, you have your correct or labeled answer. How do you actually determine whether the LLM pipeline answer is correct, or if you have other dimensions, right? How do you grade that answer on those dimensions? And you can do this in two ways, two main ways. The first is just manually, just sitting down as a human and doing it, or secondly, you can automate it with an LLM. So grading answers is challenging fundamentally because you're letting an LLM just say anything, and it's open-ended generation. So one of the ways it's challenging is using the example from Benji. Let's say as an employee, you wanted to know what your medical deductible was, and Benji returns an answer, and it has a lot of data. So it's telling you every plan, the deductible for every plan, and there are lots of facts that are present in this answer that if you were to evaluate this answer thoroughly, you would have to check every single fact. And that's very, very time consuming, and that's a very tedious exercise. Another reason why grading answers is challenging is if we take the same setup, the same question, but let's say Benji takes your question really literally and it doesn't know exactly what your deductible is. So it just says that it doesn't know and sort of implies that you should tell it what plan you're on. So I don't think this is a horrible answer. I think it's a decent answer, and I think it surfaces the uncomfortable fact that there could be multiple correct answers to seemingly straightforward questions. Now I'll talk about the specific approaches that you could take to grading answers after covering some of the general characteristics of this evaluation task. So like I said, the first approach is manual annotation. And this is a great thing to do, at least for some of your time, because it's going to give you the most accurate ground truth. So the most solid, bulletproof ground truth or label. When I say ground truth, I mean labels, where you know that these are the correct answers. This is what you want your AI system to produce. And a nice side effect is while you're doing that, you gain a lot of product intuition and understanding of different failure modes that can help you when you're thinking about how you can improve the AI product. A big downside of this is that it's very time consuming and doesn't scale. You don't want to spend all of your time, or you don't want to spend most of your day every day annotating data. You have other things to do. And so doing this a little bit is good, but you don't want to be doing this all the time. One way that you could get around that potentially is with LLM-as-Judge. So this is something that's become popular over the past couple of years, where you use an LLM to do the grading as opposed to a human annotator. And while this isn't going to be perfect, it's not going to perfectly align with how you would do the grading, and some of the grades might not be correct. Still, even if it's noisy, it can detect large effects. It's effective at regression testing. So if you want to sanity check that a small change doesn't completely tank your AI system, it's a good way to do that. And of course, because it's automated, it's scalable, and there's pretty low marginal costs, because if you want to run more evaluations, you just have to make more LLM calls, which are relatively cheap compared to the alternative. However, the big downside is you don't get this for free, because you are putting another LLM, you're using another LLM. If you really want to use it effectively, you have to build some kind of evaluation, or meta eval in this case, of your LLM. And so that runs into the same challenges that I mentioned before when you're trying to build an evaluation system. So to answer the question implied in the talk's title, what do you need then if not LLM evaluation or evaluating your answers? Retrieval evaluation is the answer, or a part of the answer. So when I say retrieval evaluation, basically what I mean is when we go back to thinking about what RAG is, right? There are two parts. There's retrieval and the generation part. Retrieval evaluation is just focused on evaluating that first component, whereas when we talk about answer evaluation, that's more of evaluating end-to-end, right? Both the retrieval and the generation, running the whole pipeline. So this is I think a really good example for why you need retrieval evaluation. So using the same question as before, let's say Benji just clearly generates a wrong answer, right? So Benji should know what your deductible is or what the deductible for the various medical plans you have are. And it just says that it doesn't have any information. So this, to me, based on my experience, I would think that this is a retrieval issue. But if you're just doing answer evaluation, you aren't able to know for sure, is this a problem with your retrieval or is it a problem with your LLM not generating the answer correctly? And so ultimately you need both kinds of tests, right? So like I said, answer evaluation is like your end-to-end test. So if you were building a car, this would be like test driving it on the road. But then you also need more focused tests in isolation that is just testing if one component is working and improving that component, which would be in this case like retrieval eval, or when you're manufacturing the car, you have to test all the components, right? So I just want to cover a lot. There are a lot of benefits, I think, to retrieval evaluation and good reasons to do it. So the first is that it's typically more objective than answer evaluation, which makes the task easier, which means that you can do more evaluations, more retrieval evaluations, more retrieval experiments, because the grading task is just easier, and also the labeling task is easier. So when you have to go and find the answer in a knowledge base or like context in the knowledge base, that's typically easier than having to make up what the correct answer or like criteria for what the correct answer could look like. This also ties into the second point, which is it's much faster than answer evaluation. So you don't have to make any LLM calls because retrieval eval is not LLM based. It's faster to label data because you don't. It sort of ties to what I said before. You don't have to craft the answer or criteria. You just have to copy and paste the relevant part of the knowledge base that's needed. And then third, it's completely automated, which we'll walk through exactly how that works later. And then lastly, and probably most importantly, it unlocks retrieval experiments. So experiments specifically aimed at improving retrieval that you otherwise would not be able to do with just answer evaluation. So I'll walk through an example of how powerful a retrieval experiment can be and its setup. So for Benji, I ran a reranking experiment where we wanted to add a reranking stage to the retrieval component. To provide some brief context so this experiment makes sense, so when we think about a basic RAG setup, typically it just uses embeddings-based vector search. And that's what we did. So embeddings-based vector search is just a fancy way of saying we take the question the user asked, we take the knowledge base, all of the context we want Benji to use, we convert that text into numbers, and then we compare them for similarity and mathematically for similarity. So the goal is to get the parts of the knowledge base that mathematically are most similar to the query. This is a pretty naive approach, and there are ways to improve it. And we found that retrieval was lacking when we were doing retrieval evaluations, and we wanted to run an experiment to improve it. And one of the ideas we had was to add a reranking step, which is the idea is that it's slower but more powerful than vector search. And to use an analogy to really solidify the intuition. So imagine if you're trying to plan a trip and you're trying to find a couple of hotels that you want to share with your group. You go on Expedia, you search for hotels, you look at the top results, and then you choose 3 that you share with your group. So Expedia, in this case, is like vector search because it's extremely fast. You get your results in under a second, but it's not the most accurate. Like, you wouldn't just blindly trust that the first result on Expedia is the hotel that you want to stay at. So if you add the re-ranker after, which in this case is you, you're a lot slower, right? Because you have to manually look through the hotels and read the descriptions, but you're a lot more accurate. So you can you can confidently pick 3 of these hotels that you would be pretty confident that would be good choices. Cool. So now we talked before about, at a high level, how retrieval evaluation works and its purpose, and now we'll get into more of the details of exactly what the flow looks like. But before that, I just want to cover the goal of the experiment and the metrics we're going to analyze from the experiment. So there are 2 goals. The first is, does the experimental change result in a better performing retrieval system? This one is pretty obvious. It's the whole point of experimentation. And then secondly, which I think goes overlooked and is a bit tricky to implement, is figuring out how much context should be passed into the prompt. So for a retrieval experiment, you have to decide how much context should be passed into the prompt, and having a systematic way to do that, I think, is really important. The reason why it's important is because it's a delicate balancing act. If you put too much context into the LLM prompt, your LLM is probably not going to perform very well. It's going to get overloaded with irrelevant context, and you're just giving it a harder task, and it's just going to perform worse. The other part, on the other hand, you really want to make sure that the necessary context is included, and the less context you give the LLM, the more risk you run of missing the relevant context. And the LLM just does not have the ability to answer the question correctly because it just doesn't have the right information available to it. Okay, so we'll start at the beginning of the flow for how retrieval evaluation works. So similar to answer evaluation, you want to label pairs query excerpt pairs, except for answer evaluation, these were query answer pairs. So let's say your query is, what is my 401k match? And then you, as the labeler, you go and find the place in the knowledge base that indicates what the 401k match is. So you do this for however many questions, and now you have your evaluation data set, which you can run against your retrieval service. So the first part of this is that you would call the retrieval service with that question: what is my 401k match, for the knowledge base that you labeled data for. And then you check if your retrieval results contain, or where in your retrieval results contain the excerpt. So one fundamental thing about RAG that I'll just quickly explain is that when you get your retrieval results, it's basically a ranked list of parts of your knowledge base. And the way you decide what context you want to pass to the LLM is with a cutoff threshold. So you have these chunks or parts of your knowledge base ranked by similarity, and then you cut off. You set a cutoff at some point. It could be, usually it's the number of chunks is very popular. There are other ways to do it as well. And so a successful retrieval case would be the excerpt appears very highly ranked in your retrieval results. It surpasses the cutoff threshold. So we would know that if a user asked this question in production, this information would be included in the LLM prompt. The LLM would be able to generate a correct answer. On the other hand, an unsuccessful case would be if the excerpt appears in a chunk that's below the cutoff threshold. So your retrieval system didn't do a good job of ranking the chunk as being very similar to the query. And so this is a case where the correct information is not going to get passed to the LLM, and your user is not going to get a correct answer. So after doing this exercise for a data set of 50 challenging questions, we're able to generate the results plotted here. And there's a lot going on, but I just want to unpack it. I want to unpack a couple of key points. So the first is that if you recall the goals of the experiment, right, we want to understand whether the retrieval system performs better, and we also want to understand the amount of context we want to pass. So that's represented by the y-axis and the x-axis respectively. And plotting it in 2 dimensions like this allows us to identify those two, let's say, parameters, that the values for those 2 parameters that we want to choose to ship. So on the y-axis, we call it retrieval recall, which is basically how often does our retrieval system retrieve the correct answer. So it's just all the successful retrieval cases divided by all retrieval cases, right? So if your retrieval recall is 80%, that means for 4 out of 5 questions, your retrieval system would retrieve the right information to answer the question. So one thing I want to point out about this is, obviously, as you increase the amount of context, your retrieval recall naturally increases, right? Because you are giving your retrieval system more chances to find the right context. If you imagine the extreme of this, if you retrieve the entire knowledge base, your retrieval recall, assuming that the answer is in the knowledge base, is going to be 100%. And ultimately, after doing some analysis, we decided on the best performing re-ranking model, which was Cohere in our case, which provided an 18% lift in retrieval recall, and with a context threshold cutoff of 8 chunks. We saw that there were diminishing gains to recall around this point, and so we thought it was a good trade-off between passing not too much context, but passing enough context so that the retrieval system would be able to get the right answer. That concludes my talk. The main takeaway, if you don't take away anything else from this, is that don't just evaluate your LLM generation if you're working on an AI product. Also evaluate how you construct context, which is a very important part of how your system works. Thank you.